All of this kind of induces a tree, right? You start in some state. There are several actions you could take, which gets you to another set of states, and so on and so forth. And this tree really kind of builds up. And you have a whole bunch, in fact, a hyper exponential number of possible stories. Well, if I have a probability distribution for all partial trajectories, then it turns out that whatever state I happen to be in right now, let's say this one, I don't actually have to care about any of the rest of the tree. It doesn't matter because I can't get there. See, as you pointed out, it's acyclical. So even though I can get from one plot point to another, I can't see a sequence that doesn't involve going this way.
Sure,
Does
but
that
there's
make
still,
sense?
yeah, that's right. But underneath that node, there's still an awful lot of other nodes.
But if I have a probability distribution for all of the next states I could get to, then I simply have to execute the action, and then I will end up in one of these states. And when I do, it doesn't matter what the other ones were. And so all that's ever happening is that I am following one particular path down the tree.
And how do we get from that target distribution that's kind of specifies the goal to a target distribution over all the intermediate nodes of the tree?
Right. That's the hard part.
Okay.
But it turns out there are easy answers to it.
Okay.
I'm just not going to tell you what they are.
Cool. And have you used this for actually making stories?
Yeah, we actually have done this for making stories, and actually shown that you can get people to feel satisfied in the stories or experiences that they're having, and you can do it in real time on the fly. And I'll just leave you with this little teaser. It involves using Koblik-Leibler divergence.
That's not exactly the most exciting teaser. I thought you were going to say something about wolves again.
Well, in the end, that's all a wolf is. I would love to talk about it, but I think it's probably beyond the scope of the class. But we'll put in the resources link a series of papers that talk about this. But the real answer is that anytime you're trying to match probability distributions, you care about KL divergence, and KL divergence is just a bunch of sums of probabilities. And sums mean linear independence. Independence means I can do them in any order, so I can basically just ignore all the things that I don't actually see, and I only ever see a finite, and not just finite, but linear in the number of plot points at any given time. And the hard part, as you recognize, is figuring out what probability distributions are for the intermediate nodes. And that can be very hard because it can require computing the whole hyperexponential tree, or it can be very easy if you have a nice function that can map partial trajectories into probabilities or some other kind of value.
Cool.
Okay.